Hello ladies and gentlemen, welcome to Tony Needs Hobbies. My name is Tony and currently I'm working on building a knife, and in order to heat treat the knife I need a little forge. So in this video I'm going to convert this old grill into a portable forge and try out the heat treating process on this Kiridashi style blade. Have fun watching.
For this project I only need the bottom part of the grill. It will not get hot, so it's just used to hold all the components together. Let's start with adding some legs. There are already 4 holes available, which I am going to drill out to 8 mm so that some M8 bolts will fit through the holes to form the legs. Then I measure everything to cut the so-called AAC blocks to size. AAC blocks are very useful for this application. They are cheap, lightweight, contain a lot of air and hence insulate really well. The outside will not get hot at all. In addition, these blocks can be cut and shaped using an ordinary saw and rasps. I need 5 blocks in different shapes. The bottom block will be square shaped. All the 4 edges will have the bottom rounded off so that it fits well in the grill. One quick upside down test fit and I'm ready to fit the blocks in the grill. Yep, that fits well. In order to get the forge really hot, there needs to be a way of forcing air in it from below. For this I will use a steel pipe with one end closed and holes drilled in it. With a pump, air will move through to end up in the fire and make it burn well. Don't use galvanized steel, the zinc will burn off and cause toxic fumes that you don't want to breathe in. One end will be closed by heating it with a torch and smashing it with a hammer on my anvil. By the way, this is the first time that I use it on camera, but I plan to start using it more often. I couldn't get the steel bright orange in the torch, all the more reason to build this charcoal powered forge. As you can see, I first flattened the pipe and then folded over one edge to close it off. I will also make an aluminum brace to hold it all together by simply bending this piece into a square. The beginning and end are then bent at a 45-degree angle and a hole is drilled into it. A screw will hold it all together. With the brace and pipe added to the forge, the last step of this build before trying to heat treat a knife with it is adding a heat-resistant refractory. Many suitable refractories can be bought, but I'm going for an alternative, a 50-50 mix of plaster of Paris and sand. It's not the absolute best for this application, but it is cheap. This means that when it deteriorates, I can just mix up a small batch and fix the cracks. The mix will be shaped into a bowl, leaving the air holes in the pipe open. It's still wet, so I'm going to set it aside for a week.
The refractory has to dry for a couple of nights until fully cured, and in the meanwhile I am going to file in the bevel in this Kiridashi style blade using this knife filing jig that I made 2 videos ago.
This knife blank was simply made by cutting a piece of 01 tool steel in the shape of a Japanese marking knife, a Kiridashi, with an angle grinder. I then cleaned up the edges with files and sanding paper. With the blank securely fastened to the knife filing jig, I am going to file in a nice bevel starting at a steep angle and working my way down. When I'm halfway through the steel, I'm going to move the guide backwards to file at a less steep angle. I'm trying to remove material as evenly as possible. You can see a line appear where the 2 planes filed at a different angle meet. Continue filing until this is not noticeable anymore. I continued filing until I was 3/4 through the material before moving another step down and smoothing the surface using sandpaper. I think this might be a mistake. As you can see, the edge is already very thin. I should have left it much thicker to prevent it from burning in the forge.
Alright, the Kiridashi has its final shape, so now it's time for hardening. I am a little bit nervous about this because I have never done it before, and I am going to find out if the mini forge can reach hardening temperature and if I'm able to harden a blade successfully. Let's see what happens.
O1 tool steel is an oil hardening steel. From what I read online, you can use many oils, including warm vegetable oil. That's what I'm going to use. I add 2 bottles to this large steel paint can. Don't use plastic as the hot blade will melt through it. Then the disclaimer. Don't take any of what I'm going to show next as advice. I am not a professional blacksmith, nor am I a knife maker. This is my first attempt at hardening and I still have a lot to learn myself. As fuel, I'm using charcoal. It's cheap, widely available, and it gets hot, so make sure to have a fire extinguisher around. With this dual action pump, I force air through the pipe into the charcoal fire, making it hot really quickly. Then it's time to heat up the oil by heating a chunk of steel in the fire and dropping it in the vegetable oil. This lowers the viscosity of the oil so that it cools down the hot blade quicker. As you can see from the color of the steel, this little forge gets hot. In order to harden the blade, I need to get the steel up to 800 degrees Celsius, but without much blacksmithing experience, temperatures are hard to judge. Above this temperature, the steel loses its magnetic properties, so a way to tell if it is above 800 degrees Celsius is by checking that. It doesn't tell me anything about the actual temperature though, so that leaves a lot of room for error. Anyway, I first heat the whole thing to oxidize it and to get a nice dark color on the blade, before concentrating the heat on the edge by putting it in halfway. When it seems hot enough, I check for magnetism. This wasn't there, so I dunked the blade in the warm oil for 10 to 15 seconds. It didn't warp, but inspecting the knife after quenching, it seems that the thin edge might have burned. I will fix that later, but first the blade needs to be tempered 2 times by putting it in an oven at 225 degrees Celsius, letting it cool down and repeat.
It has been a wise decision to experiment a bit with the heat treating process on this cheap piece of O1 tool steel before making this fully functional knife that I bought from the Alec Steele Co. Some things did go wrong and I will summarize those in a while, but first let's see how much I can save by doing an awful lot of hand sanding.
To make sure I'm sanding a flat bevel, I'm going to use this piece of granite with sanding paper on top. I start with 80 grit sanding paper, move up to 180 and finish with 240 grit. With every size I start by sanding the bevel until entirely flat, then sand in the secondary bevel and sand the back flat to the granite. What did go wrong during the hardening process? Probably 2 things. The edge was too fine before hardening. This might cause it to burn and warp. Also, I don't think I controlled the quenching temperature well enough. For my next knife, I'm definitely going to do more googling to see how I can improve that. After about an hour of sanding, I did manage to get most of the bad stuff out, so I moved on to sharpening the blade using whetstones. I have this awesome set of ceramic stones that keep my knives in good condition. I skipped the 180 grit since I sanded to a 240. The only thing left to do to finish this Kiridashi is polishing the secondary bevel on the strop to make it razor sharp. Let's see how it performs.
Ladies and gentlemen, it worked. I made a Kiridashi style blade, hardened it in my improvised charcoal forge, and now it is razor sharp. I'm really happy with the result, and I gained some experience in the knife making field, so I am ready for more knife making adventures in the future. I hope you enjoyed watching this video. If you did, then let me know by hitting the like button, and please also don't forget to subscribe to the channel for more content like this in the future. That's it for now. I would like to thank you for watching. Bye bye.